Hello, you are welcome to today's session on engineering or technical drawing. We are going to use the principles of tangency to produce this figure. So this is a past question from one university, and we are going to try that. So in order for us to be able to solve questions on tangency, we need to understand what external tangency and internal tangency means. So let's say we have a circle. So we have this circle like this. It's not drawn to scale, so pardon me. I know this really doesn't look like a circle though. So if another circle touches the outside part of this circle, we say that they are externally tangential. Now if we have this circle and then there's another circle inside, we say the relationship between them is referred to as internal tangency, or they are internally tangential. Good. Now let's begin to produce this figure. I'll be moving the paper every now and then. Okay, good. So first of all, we have to draw this line. You can start from the bottom. That's from the bottom here. You can start from the top. I'll choose to start from the top. So I will start by drawing this horizontal line 90 millimeters. That's from here to here, the centers of the two circles. So let's do that. Okay, before I do that, I want to draw my horizontal. So my horizontal is going to look like something like this. Okay, let me use this pencil to do that. So this should be a 10 line. Okay, should be a 10 line. Now what I'll do is that I'll take my rule, and then I have to pick this measurement. That is the 90 millimeter measurement on the rule. So I stand here, I open to this side. That's 90 millimeters. So I stand at this point, then I get this arc. Okay, then I stand at this point, then I get this arc as well. Now that is 90 millimeters. So there are two circles here. Let's draw the smaller circle. This symbol here, that's this symbol, this symbol looking like this. It's called phi, and it represents diameter in our drawing. So what we have to do, what it means is that the diameter of this smaller circle is 40 millimeters. So to get a radius, you have to divide the 40 by 2. So 40 divided by 2 is 20. So we need to obtain our 20 millimeters from our rule. Then we stand at this point, and then we draw that circle that has a diameter. Okay, so now let's look at the other circle. That's this bigger circle here. So the radius of the bigger circle is 40 millimeters. Always look at where the arrow is pointing. So this arrow is pointing to the bigger circle, meaning each radius is 40 millimeters. So we take our rule, we pick 40 millimeters from our rule. 40 millimeters, we pick that from our rule. Yes, that's 40. So I stand here, then I draw that. You can use deep lines to represent this because it's part of what we are looking for. Let me clean this side. Okay, let me clean this whole side. Okay, so I can use deep lines to represent this since it's part of the figure we are looking for. Okay, so we have this. Okay, so now we'll go back to our drawing. We've already drawn the smaller and the bigger circle, so we have to come to this smaller circle. The radius of this one is 15 millimeters, so we have to pick the 15 millimeters from the rule, and that will be like this, 15 millimeters. Then we stand at this point, so we have to draw the 15 millimeters. It's going to look something like this. We wouldn't draw the complete circle because when you look in the diagram, the circle isn't complete, right? Good. Now the next thing we can draw is this. This one is tangential, externally tangential to this bigger circle and then this smaller circle. So in order to get the center of this circle, we add 15 to 50, and then we add this 40 so yeah, 40, that's the radius of the bigger circle, to 50, and then we also mark the center of the circle we obtain at that point. So let's add 15 to 50, that's 65. Then we pick 65 from the rule. So picking 65 from the rule, we're going to get something like this. Good. Then we stand here, then we mark that. It should be very thin. Then 40, that's the radius of this circle, plus 50, that's 90. So we stand at 90, open to 0. So 90 open to 0, and then we mark as well. Okay, so now what we have to do is that we've been told that the radius of this circle here is 50 millimeters. So we'll pick the 50 from our rule. So pick the 50 from our rule. That'll be from this point to this point. Good. So we stand here, then we mark. We're supposed to. We can also represent that with okay. Now we are still on it. There's another thing we have to do. So when we look at the drawing, there's a smaller circle below here, that's below this one. Okay, now there's a vertical line that runs through the center of this smaller circle, and it also runs to the center of this circle. So what we have to do is that this vertical line is perpendicular to the horizontal, so we need to extend this vertical line to the down. Then we've been told that, okay, let's do that first. So in order to obtain that vertical line, we need to construct a 90 degrees from this side. Okay, so we can use our protractor to obtain the 90 degrees. That would be something like this. Yes, that is it. Okay, so we stand, we pick the 90 degrees from here. That is it. Then you get your rule, you draw a very faint line through that. Okay, so that is it. Now the question tells us that the distance from the center of this circle to the center of this other circle is 46 millimeters. So we pick 46 millimeters, that's 4.6 centimeters. Okay, so we stand here, then we mark the 46 millimeters. Good. Now the radius of this smaller circle here is 20 millimeters. We can see that. So the R represents the radius, and then the symbol like the phi represents diameter. Okay, so we pick our radius of 20 millimeters. So we stand here, we look at the circle. It's also not a complete one. Okay, so can obtain something like this, but we can represent it with a deep line because it's part of the figure we are looking for, you know. Good. Okay, we have something like this. I think that is it. Okay, that is it. Okay, now from the drawing here, we can see that this side of the circle has been linked to this side. We can also do that. So just stand here, then oh, this chicken, keep quiet, stop disturbing me. Okay, good. Now the next thing we have to do is that we can see that there's also another circle which is externally tangential to this, and the radius of that circle is 30. So we add 30 degrees to 20, we mark. We add 30 degrees to 40, that's the radius of this bigger circle, and then we mark. Then we get the center of there. So we pick let's start with the 40. Okay, so we pick 40 plus 30, that's 70. So pick 70 from here. So 70 will be like this. Then we stand here. Then we mark that. Then we can also mark that here. Okay, then now, is that enough? Let me extend that. Then now, for the smaller circle, the radius is 20, so 20 plus 30 is 50. So we stand here, open to 50. That is it. Yes. So we stand over here, then we mark that, and then we also mark that. Then now we have to, we've been told that, or we know that the radius of that circle is 30, so we take our rule, we pick 30 from our rule, These kids are disturbing. Okay, so we stand over here with the 30, you get this. We can also make that a deep line. Then we stand here, then we do same. So we have something like this. We can also make that a deep line because it's part of what we are looking for. I need to extend this one a bit. Good. Now, what else is left for us to do? Now, there's this circle over here. That's this one. We can draw this one. But before we draw that, let's construct this smaller circle with radius of 15. Now, there's a horizontal line passing through the center of this circle. Okay, and the center of this circle, smaller circle with radius of 15, is also on that horizontal line. So what it means is that we need to construct, now the horizontal line is also perpendicular to the faint line we drew. So what we have to do is that we need to stand here, we construct 90 degrees whilst we are at that point. So are we getting that? That is it. Let me see. No. Okay, from the question, the distance between the center of this circle and the center of this circle should be 46. But I think that's not what I did. I rather stood here. So I'm supposed to stand at this point. To draw this circle. So let me quickly clean that, okay? Okay, so you can see that I've corrected that, okay? Supposed to clean this very well. So I've corrected that. Now we'll continue. I repeated the same thing, just that I made sure that I stood at the 46 millimeter mark. Now all we have to do is that we need to draw a perpendicular line to this vertical line. So let's quickly do that. Okay, that is it. Good, that is it. So we have to stand at this 90 mark here, then draw a line through that. Draw a line through this. I should be a faint one, very faint one. Good. Now what we'll do is that from the drawing we can see that there's, from this point to this point is 90, and from the center of this circle to this point is 145. So we subtract 90 from 145, then the difference is what we use. So 145 minus 90, that's 145 minus 90 is 55. Good, so we have to pick 55 from our rule. Okay, so I stand here, and this is the 55 mark. That's the 55 difference. Now the radius of this circle is 15, so we have to pick 15 from the rule. So stand here and I pick 15 from the rule. So 15 will be to this point. That is it. Okay, so I'll stand over here, then I draw that circle. But once again, it's not a full circle, but then you have to represent it with deep lines, since it's part of the original figure we are looking for. I think this is okay. Good. Now we can go on and get this arc here. Thus this circle is also externally tangential to this 15 radius and then the 20 millimeter radius. So what we just do is that we add the 15 to the 30. That's this 15, we add it to this 30, we get 45. So let's pick the 45 from the rule. So we have this and that's, so I stand at the center and then I mark, then I do same for the other one. So for the other one it's rather 30 and then 20, so 50. So stand at the 5 mark, I open, so stand at the middle here, then I mark that. Okay, so we've done that. Now the radius of that circle is 30, so we pick 30 from our rule, and then we use to draw a circle. So let's pick 30 from our rule. We'll have something like this. So we stand at this point with a radius of 30 millimeters. Do this. Construct this arc. Okay, make sure it's deeper. Now we are almost done. So the last thing we have to do is that we have to draw this one. Okay, I mean this other arc here. So that arc has a radius of 70 millimeters. Here is it. So we have to pick the 70 millimeters from our rule. So we stand at 7 centimeters, open to 0. Now all we have to do is that the 70 millimeters begins from here and then begins from here and then it ends at this side. So in order to get the 2 points, what we do is that we stand at this point here, then we mark 70. That's the first point. To get the other point, what we'll do is that we subtract 15 from 70. 15 minus 70 is 70 minus 15 is 55. So pick the 55 from our rule. Then we stand at this side where we subtracted the 55 from, construct this. Then now at this point we stand here, we open 70 millimeters. Open 70 millimeters. Yes, that is it. Then we draw that. Okay, so we'll draw this. Once again, we have to use a deep line for that because it's part of good. So as we have it, that is it. Then you just clean the excess lines that are there, which you don't really need. The arcs that look longer, you just clean some part of them, but you don't clean the whole thing. So now you have to compare and see that you've had the exact work that you've been asked to do. And I think from the drawing, we've done well. We've been able to produce exactly what they required of us. So this is it. This is our drawing. So we've been able to produce this figure using the principles of tangency. Thank you very much and all the best to you, and pardon me for the noise around. Thank you. Bye bye.